Welcome to the project demonstration of real-time battery monitoring and low voltage alerting system. So here we are demonstration purpose, we are using 12 volt 1 amp rechargeable battery. So from there the voltage will be monitored continuously by this PIC16F72 microcontroller through this voltage sensor. So here the voltage sensor consists of two resistors which will act as a potential divider circuit. Why? Because the microcontroller operates at 5 volts, but the 12 volt battery is a high voltage for the microcontroller in order to read that voltage. So we need to make that voltage, it should be less than the 5 volt. For that purpose we are dividing that using these two resistors in potential divider concept. So the potential dividing ratio is 10:1, as we are using the two resistors of 1 kilo ohm and 10 kilo ohm, so which will divide the voltage in 10:1, and 1 kilo ohm across voltage is input to the microcontroller. Means if we provide 12 volts input to this voltage sensor, the output from this voltage sensor is 1.2 volts. It's a 10:1 voltage ratio. So microcontroller will code it in such a manner, if it receives the 1.2 volts, then it will multiply that with 10, as the potential divider ratio is 10:1. So here we have interfaced the voltage sensor at A0 and the voltage continuously monitoring on the 16:2 LCD screen. We have interfaced that at pin number B2 to B7, and the buzzer which was connected the pin number C4. So the buzzer purpose is whenever the voltage is less than the threshold value. So here we set the threshold value for the 12 volts battery is 10 volts. If it is less than that, automatically the buzzer will get switched on and the alert message displayed on the LCD screen. As we can see, the voltage continuously monitored. So the whole system getting power supply from this 230 volts AC input and to the transformer, which will step down the 230 volts AC to 12 volts of AC, and that is input to this regulated power supply board, which will take 12 volts AC input and provide as a 5 volts DC. It has a 3 stages. First is the rectification to convert the AC to pulsating DC, filtration to remove the pulses and to make the pulsating DC to pure DC, and regulation to make the 12 volts pure DC to 5 volts DC voltage. For the purpose we place the 7805 voltage regulator, so which will provide the 5 volts DC power supply output to the motherboard. Once it get the 5 volts power supply, it start reading input from the voltage sensor, and based on the threshold value, buzzer will get switched on through this buzzer board through the BC547 transistor board, and are continuously displayed on the LCD screen. So we are using this 12 volt battery pack, as it consists of 3 4 volt 1 amp batteries are in series. We will get the 12 volt 1 amp. So let us see demonstration. So welcome message will be displayed on the LCD first, and then after the battery voltage will be displayed here. So as of now the battery voltage is sufficient, that's why there is no buzzer alerts. Only initially the buzzer will be on and off 2 times as indication of the kit got initialized properly. So in order to make the fault, so we are using this switch to isolate the power supply to the voltage sensor to make it is 0. So when we switch off this, there is no voltage supply to the voltage sensor, so that the microcontroller will get the low voltage and it will provide us the audible alert. Yes, I'm switching off this, then you get the 0 voltage, and low voltage message will be displayed on the LCD screen. And when I reconnect that, controller will get the sufficient voltage of battery voltage and normal condition. Thank you.